We're going to continue section 4.2 by looking at inverses of functions. So in the first part in class today, we looked at inverses of relations. So now we're going to see when the relation is also a function. Okay, a function just implies that the relation has an equation that goes along with it. The function notation here has the -1 up here in the exponent in between the f and the x. Okay, so notice it does not indicate a reciprocal. It's not a negative exponent. It's just the notation to show the inverse of a function. Okay, so we need to know that notation. All right, functions that undo each other are inverse functions. Okay, so when we say undo each other, what we mean, if we have this function here, we input 3 for the x, we get 9 as an output. An inverse of this function, if you input 9, you'll get 3. X values and the output are the y values. All right, so here's example 1. Use inverse operations to write the inverse of f of x equals x minus a half, if possible. All right, so what we have, f of x equals x minus 1/2. And we're going to follow steps to write this new equation. The first step is to change the f of x to a y. Okay, now in order to write the inverse, the x and the y values, the input and output have to switch. So what we do is switch the x and y. And then our last step, solve for y. So we're going to add 1/2 to both sides. And then our last step is to write our inverse notation. So rather than y, we're going to write f inverse of x. And then we had x plus 1/2. Okay, now notice the inverse operations. We started out with a minus, ended up with a plus. Now when we have these one-step kind of simple equations, it's going to be very easy to look and see the inverse operation. Okay, so what we want to do is check, use the input x equals 1, and we just picked x equals 1 because 1's an easy number to work with. Alright, so f of x was x minus a half, that was the original. So let's see what f of 1 equals. Let's see, 1 minus a half, and 1 minus a half is a half. Okay, so what should happen if we substitute the result into the inverse? Okay, so the inverse, let's just write this again, was x plus a half. Okay, so substitute the result was a half. So the inverse of a half is, let's see, put in 1/2 for the x, so 1/2 plus 1/2 is 1. And the inverse function does undo the original. The input and output switched, so we check and we did it correctly. Okay, so this is the same as this. Okay, here's our next example. Write the inverse of f of x equals x over 3. So again, first thing we're going to do, change the f of x to a y. Just a little bit easier to work with. Okay, next step, switch the x and y. And solve for y. Okay, so y divided by 3, so we need to multiply both sides by 3. And we get 3x equals y. Our last step, instead of y, we write the inverse notation. Okay, and again, kind of a simple one-step function where this is x divided by 3, so the inverse will be x times 3. Okay, so do we see the inverse operations? Good. All right, and again, we can check using x equals 1 just because it's an easy number. All right, so we were given f of x was x over 3. So if we plug in 1, let's see, plug in 1 for x, so this becomes 1/3. All right, and that's it. Just 1/3, there's no other steps here. Okay, so let's substitute the result into the inverse. Let's just write the inverse again, was 3x what we got. So we're going to substitute the result in for x. Okay, so instead of x, we're going to write 1/3, and 3 times 1/3 is 1, which should be what we started with up here. The inverse undid the original function, so our inverse was correct. Okay, a little more complicated, just adding a step here. Write the inverse, so first, change that to y equals. Next step, the input and output switch, so x equals 3 parentheses y minus 7. Next step, solve for y. All right, so let's see. Divide by 3. X over 3 equals y minus 7. And then add 7. All right, so last step. Rewrite the y in the inverse notation. See, let's write the x first, x over 3 plus 7, or, just so you know, these are the same. X over 3 is the same thing as 1/3 x. Either way of the equation is acceptable. All right. Now, rather than checking our answer, I want to graph the original function and its inverse. Okay, so in your calculators, go ahead and y1, put the original, which was 3 parentheses x minus 7, and in y2, x over 3 plus 7. Your graph should look like this. Okay, and what I want you to notice in your graph, what we saw yesterday or earlier in our lesson, was that our function and its inverse are symmetrical about the line y equals x. So this is still true here. Here would be our line y equals x, always goes right down the middle. Okay, so we should see the symmetry here. If we folded our graph along this line, y equals x, the lines would be right on top of each other. All right, anytime you need to undo an operation or work backward from a result to the original input, you can apply inverse functions. Okay, so we're going to take a look at a real-world situation. Now, in this real-world situation, you don't switch the variables because they are named for specific quantities. Okay, and we'll see this in our example. All right, Juan buys a CD online for 20% off the list price. He has to pay $2.50 for shipping. The total charge is $13.70. What is the list price of the CD? Okay, so the list price is the original. Okay, how much was the CD before the discount was taken? Okay, so step 1, write an equation for the total charge as a function of the list price. Okay, so the equation that we have, the charge is equal to 0.80 L plus 250. Okay, now what this is, this 0.80, if the CD is 20% off, you're taking 20% off of the total price. The total price would be 100%. If you take off 20%, you're only paying 80%. So you're paying 80% of the list price plus the 250 for shipping. Okay, that's where we came up with this equation. All right, step 2. Find the inverse function that models list price as a function of the change. Okay, so now when we find the inverse function, what we're doing, since the C and the L are specific items, all we have to do is solve for L. That's really what this is saying. You don't have to switch any variables or do anything. All you have to do is solve for L. So the first thing, we move that 250 to the other side using subtraction. And then we can divide by the 0.80. All right, and this division line should be only on the other side. All right, so, and we can write it out the other way. C minus 250 over 0.80. Okay, if you want the L on the left side. All right, step 3, evaluate the inverse function for C equals 1370. Okay, well, let's put 1370 in for C. Solve, we should get 14. So the original, or the list price of the CD, is $14. And you can always do a check by plugging 14 into your original cost equation, and you should get the discounted price of $13.70. And that is it for section 4.2.